All right, today's lesson, we are looking at the equation of a line, and specifically today we are looking at this form here. It's called y equals mx plus b. All right, and the name given for this form, it's called the slope y-intercept form. So what we're going to look at today is some graphs and some investigations we're going to look at today to show us how we know that the m here is going to represent the slope and the b here is going to represent the y-intercept. Okay, so recall y-intercept is where the graph crosses the y-axis. So graph crosses the y-axis. All right, so that is the slope y-intercept form. Notice that on the left-hand side, we have to have the y. There's nothing else on the left-hand side. Our right-hand side will have this format. It's the mx plus b, which will make more sense as we look at examples. So before we begin looking at specific examples of lines, we just need to take a look at how do we know if it's a linear, if the graph is linear or not. So let's just take a look at some of these graphs here. All right, so if we look at this graph here, it's a line. Same with the second graph, it's also a line, so therefore they are linear functions. This graph is curved here, therefore not linear. Not linear here as well. It's this U-shaped called a parabola, so not linear. Here as well, we have two graphs for this function here, for this relation, 1 over x, and again, not a straight line, so therefore not linear. Here we have a linear graph, a linear here as well, and this one is also curving, so therefore it's not linear. So the only ones that are linear was the first one, the second one, this one here, and this one here. Those are the ones that are linear. And the nonlinear ones, this one, this one, this one, and this one, those are non-linear. So the way you can tell if a graph is going to be linear, meaning a straight line, is by looking at your x and y values and making sure they just have an exponent of 1. So if we look here, y and x, they both have exponent of 1, exponent of 1, exponent of 1, exponent of 1. When we get to nonlinear, you will see that the exponents change from 1. Here we have a cubic function, exponent of 3. That would be this one here. So the graph would look like this. A squared graph, exponent of 2 looks like this, and so on. So if you have a graph that's of a straight line, the x that we see and the y both have an exponent of 1. Okay, so what we have defined then is for a linear equation. So far we've just looked at this general equation, y equals mx plus b, and we know that the graph of a linear equation is a straight line. So let's take a look at our graph here. We have 2 over 3x minus 1. So we said that the 2 over 3x represents the m right here, which represents slope. So that little m represents slope. All right, so use the sketch and points A and B to find the slope. So let's take a look at our slope first. So here's our point A and here's our point B. So we know we could figure out our slope just by looking at rise over run. So if we look first, we know our line is going up from left to right. So we know it's going to be a positive slope. Next, we can look at our rise. So our rise is 2, positive 2, 1, 2. All right, there's our rise of 2, and our run is 1, 2, 3. Our run is 3. So therefore our slope is positive 2 over 3. Next, we're going to look at our y-intercept. So the y-intercept is where the graph crosses at the y-axis. So if we look here at our graph, this is our origin right here, 0, 0. And our graph is crossing the y-axis here at -1. So our y-intercept therefore is -1. Now take a look at our form, which was our slope y-intercept form. M represents slope, and when we look at our form here, 2 over 3, that is our slope. B represents our y-intercept, and if we look at our example here, -1, that is our y-intercept. Okay, let's take a look at here. It's just a summary. The slope is the coefficient of x, again 2 over 3. The y-intercept is that constant term at the end, which was our -1. So again, that's in our y equals mx plus b form. Let's take a look here. We have Janine sketched the graphs of 2 linear equations. Use the grid to determine the slope and y-intercept of each graph. So we have 2 lines. One line going up is the y equals 2x plus 1. We have a second line here going down. The equation of the line is y equals -5 over 2x minus 3. Okay, so let's take a look at y equals 2x plus 1. And let's take a look at the slope of that line. So first of all, the line is going up from left to right, so we know our slope is going to be positive. So let's just count our rise from here. We can use another point here. So our rise is 2 and our run is 1. So therefore the slope is 2 over 1, which is just 2. So our slope is 2. Let's take a look at our y-intercept as well. For this first line, it is crossing our graph here at +1. So our y-intercept is +1. So if we look at our equation, the slope is 2, which is m, and our y-intercept is +1, which was the b. Let's take a look at our second line here. The equation is a -5 over 2x minus 3. So counting for our slope, our line is going down. So 1, 2, 3, 4, 5. Our slope is -5 for the rise and over 2. So our slope is -5 over 2. And where is our graph crossing the y-axis? It is crossing here at -3. So our y-intercept is -3. And compare that to our equation of our line. Our slope is -5 over 2 and our y-intercept is -3. So what we know from our equation, y equals mx plus b, is our slope is represented by m and our y-intercept is represented by the b. All right, our next example, Hashib used a graphing calculator to graph the linear equation 2y equals 5x plus 8, and this is the graph. All right, so the graph is of 2y equals 5x plus 8. So let's determine the slope and y-intercept of the graph. So our slope, we'll just use rise over run. We'll use these 2 points. So our rise is 1, 2, 3, 4, 5, and going over 2. 1, 2. So our slope is 5 over 2. And looking at our y-intercept is occurring right here at +4. All right, so our slope is 5 over 2 and our y-intercept is at +4. Well, this doesn't match the equation. The reason being is it's not in y equals mx plus b form. There's still a 2 here. You have to isolate your left-hand side so that it's exactly y equals mx plus b. So we have to divide this equation so that the left-hand side is just y. So let's take a look at how we would do that. So our equation for this example, this was number 3 on page 5, 55. So our example here, the equation of our line was 2y equals 5x plus 8. All right, so this form is not in y equals mx plus b form. So what we have to do is divide both sides by 2, like so. Once we divide both sides by 2, we can now have our equation written in y equals mx plus b form. So 5x divided by 2, that's just 5 over 2x. And then 8 divided by 2 is 4. So now our slope, m, is 5 over 2. And our y-intercept, which is our b, is equal to positive 4. So now if we go back to our graph, it makes sense that our slope is 5 over 2. Our rise was 5, 1, 2, 3, 4, 5, and our run was 2. So slope is 5 over 2, and our y-intercept was here at positive 4. Okay, so we have two examples here of linear equations, and all we need to do is figure out what is our slope and what is our y-intercept. So looking at our first equation, it is written perfectly in y equals mx plus b form. So our slope here, slope is 3, and our y-intercept is positive 2. Our second equation here, it's y equals 7 minus 2 over 3x. So the only thing a little bit confusing about this one is that it's not written exactly as y equals mx plus b form. So all you need to do for this one is just switch the 7 over to this side. So it's just y equals negative 2 over 3x plus 7. All right, it is a positive 7, and our slope is negative 2 over 3. Okay, so slope is negative 2 over 3, meaning the line is going down, and our y-intercept is positive 7. Okay, so our next example here, we have a 6y equals 8x plus 1. We need to determine our slope and our y-intercept, but we can't do that because on our left-hand side, we have 6y. So we need to put it into y equals mx plus b form. So we have to divide both sides by 6. All right, so once we do that, we get y is equal to 8x over 6. I can reduce that, so I'll just put that here as 8x over 6 plus 1 over 6. All right, any fractions that you can reduce, make sure you do so. So here, 8 over 6 can be reduced to 4 over 3. So it becomes 4 over 3x plus 1 over 6. All right, so now we have it in our y equals mx plus b form. So our slope is 4 over 3. So rise over run, and it's a positive slope, so the line is going up from left to right. And our y-intercept is, our y-intercept, I'm going to go like this, is 1 over 6. Okay, so our next example here, we're given our equation. Our equation is y equals 2x minus 5. And we have to basically be able to graph this using what we are given. So what we are given here from our equation is that we have a slope of 2, and we have a y-intercept of negative 5. All right, so once you have these two pieces of information, you actually can make a graph. So you would start with your y-intercept at negative 5. So 1, 2, 3, 4, 5. There's negative 5. And we know we have a slope of positive 2. So that means our rise is 2, our run is 1, because the slope is 2 over 1. All right, so knowing this, we can start drawing other points on this line. So we would go up 2 over 1. There's our next point. Up 2 over 1, up 2 over 1. And once you have minimum 2 points, you can draw your line. So therefore, just like this, there is our line for that graph. And you can verify this graph as well just by putting this into your graphing calculator, y equals 2x minus 5. Okay, so next example, we are given the equation 2 over 3x minus 6. So again, just from our equation, we can tell what our slope is. I'm just going to put it right here. That's our slope. And negative 6, that's our y-intercept. All right, so again, with a question like this, you need to just start by plotting your y-intercept. So our y-intercept is at negative 6. So I'm just going to plot that. So 1, 2, 3, 4, 5, 6. There's one of the points on the line. Next, we have our slope. It's 2 over 3, meaning our rise is 2 and our run is 3. So up 2 and over 3. 1, 2, 1, 2, 3. There's our second point on the line. You can continue to make points up 2 over 3. So 1, 2, 1, 2, 3. Up 2 over 3. 1, 2, 3. All right, and then you would just connect the dots, and you have your line. All right, so if you have an equation written in y equals mx plus b form, you get your slope, you get your y-intercept. Using those two pieces of information, you can get your graph of the line. All right, so our next example here is we're given some information. A line is passing through a point 0, 2, and it has a slope of 5 over 2. Write the equation. So what we have to notice here is a line is passing through a point 0, 2. That means the x value is 0, the y value is 2. This means we are looking at the y-intercept. All right, so we know that our equation written in mx plus b form, we know that the m represents our slope and the b represents our y-intercept. So since we already have those two pieces of information, we just have to plug them in appropriately into the parts of the equation. So our slope is m, so 5 over 2x plus b, which is our y-intercept, which will be just plus 2. So there we have it, our equation for that line. All right, so in this example, we're told each line on the grid passes through points with integer coordinates. In each case, state the slope and y-intercept of the line and determine the equation of the line. So line 1 is this one here. It's shown right here. It's line 1. And then line 2 is shown here. This would be line 2. So first of all, line 1, it's a positive slope. So let's calculate our slope first. We have 2 points right here. We have a rise of 1 and we have a run of 1, 2, 3. So therefore our slope is 1 over 3. All right, so we can put that into our equation as 1 over 3x. Next, we just have to look at our y-intercept. Our y-intercept is right here at negative 4. And that's the b part of our equation. So our equation is 1 over 3x minus 4. Let's look at line 2. It is going down. So remember, your slope will be negative when the lines are going down from left to right. So our slope, we have 2 points given right here. So our slope is 1, 2, 3. So negative 3. And our run is over 2. So our slope is negative 3 over 2. Our y-intercept, so it's crossing our y-axis right here. That's at positive 2. So our line is negative 3 over 2x plus 2. Word first. So our next example, we have to come up with the equation of a line that's parallel to y equals 1 over 3x plus 4, and it's going to have the same y-intercept as y equals 6x minus 7. So this line that we are looking for, if it's going to be parallel, the parallel slope, remember slopes of parallel lines are the exact same, so our slope would be 1 over 3. And it says it has the same y-intercept as y equals 6x minus 7. The y-intercept for this line is negative 7. So therefore our y-intercept is negative 7. Since we have these two pieces of information, we can write out our line in y equals mx plus b form. Slope will be 1 over 3. And then our y-intercept is negative 7. So 1 over 3x minus 7. That is the slope, and that is the y-intercept. All right, so next we are looking at part B. We have to figure out the equation of the line. The line is passing through the point 0,9 and is perpendicular to the line joining 2, negative 6 and negative 5, 0. So the first thing we have to do is figure out the slope of this line with these 2 points. All right, so our slope, 0 minus negative 6, that's our rise, and our run, negative 5 minus 2. That leaves me with a slope of negative 6 over 7. All right, so that's the slope of this line, but we are trying to figure out the line that's going to be perpendicular to it. So our perpendicular slope will be the negative reciprocal. So we flip it, and it's going to be now 7 over 6. All right, so the original slope was negative 6 over 7. Therefore, the perpendicular slope is 7 over 6. All right, so our y-intercept, we know the line is passing through here, 0, 9. That's the y-intercept. All right, so our y-intercept is 9. So since we have both pieces of information now, we can put our equation in this mx plus b form. So our slope is 7 over 6, x plus our y-intercept, which is 9. Okay, our next example is exploring horizontal and vertical lines. We did already explore horizontal and vertical lines, so this is just a little bit of a recap. So let's take a look here. We have line 1 and we have line 2. Those are our horizontal lines. We have another line here, line number 3. That's a vertical line. So if we look at line 1 and both line 1 and line 2, they are horizontal lines, therefore they have a slope of 0. All right, so both of them will have a slope of 0. The y-intercept for line 1 is at positive 4. So y-intercept is positive 4. So when we're putting this into our y equals mx plus b form, 0x plus 4, we just end up with a line called y equals 4. All right, it's just crossing right through y equals 4, and there's no slope. Knowing that, you can predict the equation of line 2. Again, there's no slope. It's just going through here at negative 6. So the equation of the line would be y equals negative 6. All right, so like we had discussed before, when we have horizontal lines, they have a slope of 0. When we have vertical lines, the slope was undefined. All right, so here we're looking at line 3, which is a vertical line. the slope is undefined. It doesn't have a y-intercept. It's not crossing the y-axis. So there's no y-intercept. All right. So what could we give as an equation for line 3? So for line 3, it is crossing our x-axis. It's crossing the x-axis at -3. All right. So since we have that, we can give our equation as x equals -3. Now, because this graph is written as x equals -3 and not in the y equals form, you cannot use a graphing calculator to verify that, okay? Because all the graphs that we put into a graphing calculator are always in the y equals form. All right, so just lastly here, the equation y equals k, that means we have a horizontal line, it's going through 0k. And if we have an equation x equals k, we know it's a vertical line, and it's going through the point k, 0. All right, so our last example here, what is the equation of a line passing through the point -2, 8? It's parallel to the y-axis. So part A, if it's parallel to the y-axis, we know it's going to be a vertical line. All right, so therefore our line will be x equals to -2. All right, because it's passing through at -2, so about here, -2, and it's passing through there. And if it's parallel to the y-axis, it will be a vertical line. If it's parallel to the x-axis, it's going to be a horizontal line. Here's our x-axis. So if it's parallel to the x-axis, it has to be a horizontal line. So from our point here, we know that it will be at y equals 8. All right, so y equals 8 somewhere up here. So it would be passing through like this as a horizontal line.